Welcome back, ACES people. So I wanted to take this opportunity to share with you guys, because I got a suggestion to let's go over some technical aspects in our testing and all the things that we put in to what it takes for us to really develop like a new system for you. This is my prototype. This is like the one that it's like keeping for my personal stuff, but this is the prototype for the Killshot Fusion. You know, we just recently released the Killshot Fusion. We did install in the big block. We've talked about it on our Tech Tuesdays and all that. But this is the actual, I put 5,200 miles on this thing on my personal vehicle, back and forth to Kentucky. It's fantastic. But as you can see, you know, we went through the whole thing. I've cut some wires and put some cheap electrical tape on there just to get a sensor length right. I've modified the actual wiring over here for the, well, this is for the fuel pump and the keyed switch 12 volt, and just went through all the different wiring lengths and really just kind of temped them all together to get the length correct, so that when it comes into let's make a production version of this, how many combinations will fit. So I took the average across small blocks, big blocks, and a bunch of different Ford, Chevy, Mopar applications that I've bolted this thing onto, to figure out what's good length of wire that's going to most commonly fit your applications, being you, the people, that is. And that's just one of the many things we've done. But I made some talking points over here. I'm going to go through them. I want to talk about this throttle body and how we developed that. Now, this one has ran. It still runs. It still has a really good tune in it, by the way, but I'm going to keep that because, you know, it's probably going to go back on my Tahoe, because I like the fact that it has a raw, unfinished ECU cover on the side of it. It's, you know, it's been beat up a little bit. I've dropped it twice. It's a whole thing, but this is a prototype. So I do this so that when we roll something out, it's going to be more correct for you guys in your applications. So anyways, the insane host of tests we do with these things is well, it's a little bit staggering for me, because, you know, I come from a huge background in aviation, which, as you know, is top quality, top tier. There's so many inspections that need to be done, and we're doing a lot of the same stuff here. We do the X-ray testing. That's pretty normal, but we're checking to make sure that the aluminum this throttle body is made out of didn't have a bunch of voids in there, so you don't end up with like a weird fuel leak somewhere, or some kind of, you know, the injector don't go in correctly, or the screw holes are in the wrong spot, or none of that stuff. So we make sure to X-ray test it. We also do CMM testing as well. So we'll have an actual machine go around and we'll probe a bunch of different points, and it has to be within the criteria, because our discharge rings in here, well, they're cryogenically installed, so they have to shrink up, go in the hole, and then expand back out. And that's a whole operation in itself. But the accuracy of these throttle bores alone, you know, they have to be very spot on. They can't be off in any real directions, otherwise these things ain't going to fit, and then we're down a throttle body and we have to go on to the next one. But we're not just going to push it out. You know, we're not going to like, hey, it's good enough. We don't do that. We have too many quality checks for that. When we run check these things, when we're actually manufacturing, we run them on an actual live engine. So if you get one that smells a little bit like fuel, that's because we ran the thing already. We made sure all the injectors and everything worked just fine. Because we have the ECU on the side, we had to do a lot of interesting and very science-based things. Lots of engineering went into it. Like the epoxy we used. It's a high temperature. It does very high temperatures and very low temperatures, but it doesn't expand or contract too much to damage the circuit board. So it does with a higher temperature range and extreme temperature. So we do all these environmental testing, high temperature, low temperature, but we also put this thing into a salt brine as well to simulate weather and like long-term exposures to salty environments. So with that, it's, you know, you can corrode these things up pretty good if you put them in extreme conditions, but that's why we use these types of coatings on this material to help prevent that. You get all that surface corrosion on there. No, we're just going to science that up a little bit for you so that you don't have to deal with the same things. So there's too often that, you know, manufacturers will skip over these processes to make sure that not only are we building a good product, but how long is the product going to last? What kind of environments are people going to put these things in? So we do the temperature, the vibration, the environmental testing. We put them into electrical storms as well to make sure that there's no like RFI, EMI things that's really going to mess with it. But then again, you know, we get into the engineering side of stuff. We put in a 4-layer PCB. And let me double check right here. Let's see, there's a whole list of it. But, you know, we did put the power layer of that PC board on its own separate deal. So any of the interference that may develop from having a 4-layer PC board kind of goes away because it separates it and gets all those circuit paths out the way of each other, so they're not really too close together. They're close together, but the layers kind of insulate in a way. We integrate a whole bunch of stuff like the MPU, which is the memory protection unit itself. Of course, just so much. We put in dual ignition drivers. So we got dual MOSFETs inside of this thing to help separate the load on the coil itself and deal with heat a lot better, deal with more coil options a lot better as well. Just because that's one of the biggest failure points that we've seen in this industry with people putting the actual ECU on the side of the throttle body ain't just the environmental stuff, but actually the load of everything. So because of the actual load of the coil and a bunch of other subsystems that come off of this throttle body, it generates a lot of heat, which slowly degrades the chipsets. That's why instead of using industrial grade chipsets, we used automotive grade chipsets to help bring that into reality. Automotive spec is about 125 degrees C, and everything has to meet that spec. The wiring harness, the shielding, the connector, all the circuitry inside, the potting compound. That way this thing can sit in a hot environment for a long period of time and not really suffer any kind of damage that's heat related. And it throttles itself. So if it does get above that range of like, hey, we've exceeded that, the MCU inside has an internal health meter basically that says, hey, you've gotten too hot, let's just turn it off. Let's just turn it off and protect it so you're not smoking your ECU. That way when your car does cool back down, say you got an overheating problem, this thing's going to try its best to protect itself in all directions so that when your car finally cools down, you get a little bit of antifreeze back in there, you hit the key, she's going to fire right back up. And I recently actually tested that as well by getting an engine hot enough to the point that I got to shut one of these things down and it didn't break it. Actually, I shut this one down and it didn't break it. It didn't melt anything. It didn't do anything funny. It just, the engine cooled back down. I topped up the coolant, started it back up. It's fine. It's still here. I can go bolt this on a vehicle and actually go give it a run. Not a massive deal. A lot of the other aspects we did, because EMI, RFI, all that stuff, or electromagnetic interference, radio frequency interference. A lot of people, you'll see other systems and they'll wrap stuff in tin foil and do an incredible amount of strange things to help mitigate that tiny electrical storm that's invisible to our eye under the hood. So if you get an electromagnetic field detector running underneath the hood of your car, your AC compressor, your starter, all these different things is going to generate, especially your ignition system, is going to generate this huge field of electromagnetic interference, which through lines of flux is going to carry back through your sensor wires back into your ECU and confuse it. We've built in the extra hardware because of the type of PC board we're using with multiple different layers that does filter those things out, and the chipsets we're using, which actually filters that stuff out as well. So when it comes into that, it's like, the hardware side we're very filtered, but also internal of the chips as well, there's software, there's redundant software built in to actually filter that out, to look at the 1 and 2-bit stuff, to say like, hey, this is rogue data, we're not going to do anything with it, let's filter it out, no problem. Just gets rid of it and interpolates in between and carries on exactly what it thinks you're doing. So we don't have to worry about crazy, like looks like laser light shows as it goes in your data logs. You just end up with, well, that was a little bit funny. It's still running though. Not too bad. So a lot of the updates we've done with this Killshot Fusion is like with the linkage itself. We went with the progressive linkage. We made sure this is all nice and smooth and does its job. Nothing's locking up or binding or any of that stuff. I don't know. I did bend mine. This is where I dropped it at. It's fine. It didn't mess up anything. You'd think it'd warp a shaft. No, it's a very, very strong setup here. But some of the other improvements, let me think here. How the injectors run as well. Like we've improved how these actual injectors fire based off of data we've collected from engines running of Chevy versus Ford and all that stuff. We looked into, is there more efficient things we could do with the pattern and even how it injects the fuel? And the answer was yes, so we did that. We went ahead and improved that efficiency just to get a little bit more out of this whole unit to meet better peak performance requirements. But the biggest question that I'm seeing out there on the web as we're releasing this is why? Why would we do this? And yes, we're doing it for the people, of course. But some people, we wanted to offer more options. Some people, they like the ECU on the side of it. So we took the hard engineering approach. We engineered it to pieces, broke it down, put it in all kinds of awful tests, really ran it through the ringer and come up with, this is going to be good. This is going to be really good. And then it come here and I started testing and breaking and pushing and changing. And that's the question that always comes around. Why? I mean, it's because of you, the people. We want to add those options. If you want the ECU off of this thing and mounted to a firewall and you want more expandability and you want a different thing or you have something else in mind, we want to offer that option too. The ECU's on the side of this one. Say you want to keep your car real clean, just basic, get it up and running, but still have 650 horsepower range, still do 1,000 CFM of airflow, then we have that too. We're just offering different price point, different options for people that are requesting these things. And you know, a couple comments, all of a sudden we started looking into it, and then we started engineering into it, and then we started proofing it and testing it and prototyping it, and then we made it into the manufacturing, and we got it out to you. And we're going to do the best we can to make sure the products you guys are requesting for us and the products we're developing is the best. And that's really what we're doing here. That's the big answer for the why question. There's lots of whys, and keep asking the whys because we're going to do our best to get you those answers. So thanks for taking this walk through this particular prototype. The production one, if you want to see that, check out our Camaro install video. Also go to acesefi.com. I mean, we got a pretty good sale going on, and we got a lot more coming out just like this and just like many other things, and it's because you're asking for them. So I hope that helps.